Hello, welcome. Thank you for joining us today. We're broadcasting live from Park City, Utah, where I am, and Mark and Lauren are in California. We're super happy to have Mark back again, and big thank you to my dear friend Adil for introducing me and Family Office Insights to Mark and his organization. It's truly fascinating stuff. We're going to hear an update from our last webinar, and then go through the information that Mark has prepared for us today. Just a reminder, you're so welcome to make sure that if it's interesting to you or anybody else that you might think it'd be interesting to, going forward, you're welcome to connect directly with Mark, and I'll make sure that everybody has the information to do so post-webinar. As you know, we don't stand in the way. We want to make sure that you can connect directly with Mark. The objective of today's webinar is to raise money for Mark's organization, and so you'll hear more about that in detail. So we're also going to be recording this and posting it, hopefully somewhere, Mark, where they can also see it in conjunction to your website, as opposed to posting it at Family Office Insights. We don't need to drive traffic there. And then again, we'll make sure that everybody is connected directly with Mark and Adil post-webinar. So again, thank you for spending a little time of your afternoon. And with that, Mark, good to see you again. Thanks for doing this once again, and take it away.
Okay. Yeah, thanks, Arthur. And good morning, afternoon, maybe evening, depending on where everybody's at. Used to all these time zones. Yeah, so Mark Hinds, CEO of an entity called Singularity Group. And basically what we've been doing for about the last 15 years is working to develop a set of technologies based on a pretty radically different understanding of physics. And the premise behind what we do is say, we believe that pretty much the majority of things happening in the world are sort of what we call dissonant to how nature functions, meaning, we're looking to force nature to be manipulated as far as we can push it, whether it's blowing a hydrocarbon up, or splitting an atom, or using chemicals to do particular things. And the premise behind what we're doing is we've created a pretty significant body of science, published many papers, saying if we could really understand how nature functions, we could probably solve some pretty complex problems. And so Centuri, which we're going to talk about today, really focuses on two aspects of that. One is how do we create a material that basically is strong, light, can solve many problems of what we would want to use from even what we'd say past green materials to build things from. And then how do we use our understanding of electromagnetism to solve energy? And so what Centuri is, it's a combination, if you will, of a very interesting composite material that we've developed, and then a set of principles and systems that we've developed in electromagnetism to produce a new type of wind turbine. So we've been in development for about a little over 18 years in the development of the technology. And we've had some applications coming to market. And since we presented last with Arthur and his team, had some really good advancements in interest and obtaining some LOIs that we're hoping to be able to convert to purchase orders pretty quickly. The LOIs alone amount to a little over about $2 billion of interest in the wind turbine, and a lot more coming forth. So having said that, that's kind of the background, and let's jump into the heart of the matter and really show you what we're doing. So go to share screen here, boom, and then view full screen mode. Okay, and Lauren, does that look good? Okay, great. Thank you. Okay, so again, we started almost 18, 19 years ago with the composite. I don't know if anybody's aware, but there's something called the Goodyear moment, where the first rubber tire was made. It was sort of an accident in the lab, and I'd like to say we had our genius mind all together to create this, and we were working on it, but definitely had a Goodyear moment where something really special came out of that. And what came out of that is this composite material. So the material is 6% the weight of steel. You can see some of the bullet points here. 10 times the strength of steel. Fire rated to 1350 C, almost 3500 F. No heat transfer, which what that really means is if this right here was even 1350 C and I'm holding it here, there's no heat transfer in any part of the material. It won't rust, it won't corrode, won't be affected by acids. So we can make, let's say, a vessel, and it would have the same attributes of molecular density as stainless steel, whereby in that vessel we could put diesel fuel one day, wash it out, and the next day put milk or water in there. So in that regard, it's really extraordinarily unique for a composite. The majority of it is made from natural resources. There are some things that aren't fully, but mostly. And very importantly, the method of the construction of the composite and the use of the composite is all done at ambient temperature, ambient pressure. There's no autoclave, there's no anything. So scaling this is basically just an issue of floor space. And you can see it's basically tables and forms and floor space. So that's the ideas behind the composite. And I won't go through it all today, but multiple third-party tests with testing of PSI, many things. So all of these claims have all been third-party tested.
Hey, Mark.
So yes.
If you jump back to that prior slide.
Sure.
I'm not sure you have an example, but I'm fascinated on why the no heat transfer is important. And do you have an example of an application why that would be important?
Yeah, so it's important in a few applications. So let's say you have, so as you're going to see in a moment, in one of the applications, we've built, I think our first one was a 540 square foot, say, tiny home. And I think we're going to go to market with about an 850 square foot one. But so let's say that that home is in a place where there's a fire. So first of all, one of the great things is that the material is not going to burn unless it's over 1350 C or 3200, 3500 F. But importantly, let's say the material is being exposed to 3000 degrees Fahrenheit. So the material is getting hot because it's being exposed to the heat. But let's say wiring or plumbing or anything even next to it within a few inches away, there's not going to be a heat transfer to that. Or let's say you're using it in the application of heavy equipment or generators, compressors, things that have tremendous amounts of heat output. You can have it right next to it. Since there's no heat transfer, a lot of the dynamics that have to be considered when building things that produce a lot of heat or in those environments are heat transfer, right? Like, okay, you have to have insulative qualities. You have to do all of these other things. All of that goes away with the material.
Yeah, so in a container, for example, you could have a motor, electric motor generating a lot of heat, and you could have it within the container of this, and it wouldn't melt or burn or be hot on the outside.
That's correct.
Yeah, super interesting.
Yep.
Thank you.
Okay, and although we have many, many potential applications, as I don't know who's on the call in your background, but I've been working with these really extraordinary minds and helping develop technologies for almost the last 20 years in various applications. And the number one challenge is always, we can keep inventing, but unless we really focus and get something to market, then you know, it doesn't make a whole lot of sense. So although here we list 4 things, right now we're really focused on 3: the wind turbines, the housing, and the construction. We have a lot of interest in the marine, but it just takes a lot more energy and resources. So we're going to do that a little bit later, but you'll kind of see as we go. So, I just realized that this may not be fully embedded in here, but maybe when we're done with the PDF, I'll take a moment and then I'll load this wind turbine in a video so that you can see it actually working. So, so this is really a pretty extraordinary technology. So this is our wind turbine. It's a little difficult to see in this image, and maybe we should actually, it's making me think that we should probably do like a 3D cutaway. Just thought of that. So, but what you see is that there's that middle part, has the skeleton in it, and that's sitting in a ring at the top and then a ring on the bottom. And then the top and the bottom both have electromagnets in it and coils. And so basically that middle part is magnetically levitated inside of that bottom and top ring. So nothing is touching anything. There's no moving parts. You'll see in the video. So right now that handheld little thing that says 5.2, that's a wind speed meter. The turbine is actually 30% efficient at 2 miles per hour of wind. And our new unit, which is about 20-something feet tall, is producing 1.1 megawatt. So we have the world's first technology that's producing electricity at very, very low wind speeds, down to 2 miles per hour. It's 100% efficient at 9 miles per hour. There's zero maintenance. We don't really know how long, maybe 30, 40, 50 years. You just have to clean up some weeds around the area. It's producing massive amounts of wind. And actually, we can stack that unit one on top of each other. So the entire profile would be 60 feet tall, but then it's producing 2.2 megawatts in basically a 30-foot footprint, which, to give you an idea, you know, one current windmill, which has about 3,000 parts, you know, gears, transmissions, all of these things, and the whole world's starting to see it's a very bad technology. You know, Vestas, GE, I think they've lost about 70% of their value just in the last many months. But for about a 2.5 megawatt unit, you know, they need about 2.5 acres. In 2.5 acres, we could have 100 megawatt of our turbines. We've had one installed. What is that? I forgot the name of, near the college town in California. Oh my gosh! But one on a pier where they've been doing studies on for 2.5 years. Not one bird kill ever. There's no back EMF, which is another issue of these, you know, large windmills. No maximum wind speed. I can show you another video. We've actually had a small one installed in Iceland at up to I think like maybe 50 minus F, and over 100 mile per hour winds, 120 mile per hour winds. So there's no maximum wind speed. So we're really excited about the technology. And right now we have LOIs, which they're waiting to convert them to purchase orders. When we can show manufacturing, which that's one of the reasons we're having this presentation, is to be able to begin scaling the manufacturing. But currently right now, a little over $2 billion of LOIs. And then very easily, once we feel confident taking them, you know, multiples of that. And for many reasons, which we can go into, you know, a lot of the wind farms are failing, and they could just pop ours in. And you know, China alone wants to do 1,200 gigawatts of wind. So there's all over the world, there's interesting opportunity. But Arthur, did you want to ask something?
Yeah, I was just noticing the other day of these boneyards of windmill whatever you call them, fans.
Yep.
You know, they're just
Blades.
the blades. Thank you.
Yep.
That have accumulated because they crack and the maintenance is terrible, and the economics of that has all been challenged many, many times. What I was going to ask, without you disclosing specifically necessarily, is what type of entities are the LOIs from? You know, are they government entities, solar farms, wind farms? What type of groups have been really interested in this sort of thing?
Yeah. So I think of the 3 or 4 that we have right now, 2 or 3 of them are governments. So the UK government, and they even announced like what a multi-billion-dollar project yesterday. It just announced it. But so UK government, Goa, India, Australia, which I'll share in a minute. We're already in production with one aspect of our technology in Australia. We're supposed to be going there on October 2nd or 3rd to meet with the U.S. representative from the U.S. in Australia, the ambassador there, which everybody knows, maybe Carolyn Kennedy. And they're interested in a little bit over 100 megawatt. And then there's multiple entities that spent a lot of money on wind farms that are failing. And so we haven't memorialized anything with them yet. We've just sort of been focused on trying to get this done and get the tech to market, and then we'll engage them. But there's probably about maybe 20 gigawatt of interest in current wind farms that are having very significant problems with their windmills, which, yeah, there's going to be boneyards of windmills all over. And it's been amazing to us for years that they were allowed to perpetuate.
Yeah.
But that's
the economics
that's coming to an end.
Yeah, it doesn't work. Yeah.
Yeah.
Mark,
Yeah.
do you want to take a?
Sure.
Steve asked, how does this interplay with 3D adaptive robotic construction, which I think is 3D printing, additive manufacturing?
Yeah. So fortunately, our process, our manufacturing process, is actually extremely low tech. So there probably wouldn't be much of a place really for robotics or 3D printing at the moment. So basically, let's say to make the turbine, actually, I think you'll see, I think in here there's a little bit, but for anything that we make, basically what we do is we create a form, and then in that form we have a proprietary fabric that we lay in the form, and then we basically cover the form with sort of like a big Ziploc baggie. And it's almost like, you know, if you've got, you know, if you're one of the folks that preserve your food and all that, you got the little thing that sucks the air all out.
Of it. Yeah.
Yeah. That's almost how it works. Where basically we then vacuum in our resin, which is, it's multiple resins that we then get to come together, and then they interact, and we can regulate the cure rate. We can regulate many things with the resin depending on what we want it to do. But then, so we just vacuum the resin in over the form, and that's the process. So the manufacturing is incredibly inexpensive, very straightforward. And I would love to have a robot for something, but if we can find something we can use them for, which actually there is a piece of metal that we have to use, I'll show in a moment, with the shipping containers because of the current registration needs for shipping containers. But that might just be CNC'd. So at the moment, not much of a need for robotics or 3D.
Yeah, so the 3D printing just complicates it. It's not additive.
Yeah, it's a cost. We can go so much faster than 3D printing or robotics ever could without the need for any of it.
Yep, totally makes sense.
Yep.
Let's just take one more. Is the system connected to a conventional generator? This windmill, I believe.
Yeah. So the turbine is the generator. So that top ring and the bottom ring actually have. So we make our own magnets, And actually, we have not patented them. They're a trade secret, because if we patented, then people would know what we're doing. But it's actually really, really, really fascinating what we've done. Maybe I'll take a second to share, because it's very important. So, I think most people probably understand, magnets have like a north pole and a south pole. So they have, information coming in and information coming out, and that's basically called flux. So the north and the south of the magnet, that's the flux path that the magnetism or the electromagnetism moves through. What we've done is we've created a set of magnets where we can basically manage flux, which that may not sound trivial, which that part we've actually patented, but it's really extraordinary, because just like how like a circuit board moves electrons through a path, now in the electromagnetic field, we can actually move flux through a path. So basically, let's say a current magnet, you may be getting 3 or 4% of the potential of the magnet. The rest of the flux is just going off into space. We can now basically take almost 100% of the potential of that magnet, and we can manage and move that flux to do what we want it to do. So anyways, the magnets and the coils are all built into the top of the ring, and then the top of the turbine blades, and then the bottom of the ring and the bottom of the turbine blades. And so the generator, that is the generator. So we don't have to have any, there's no metal parts with the exception of the copper wire in the coil, and then the neodymium in the magnets. But besides that, that is the generator, which is extraordinary. Does that answer that, Arthur? We may have lost Arthur.
Yeah,
but,
no, my
okay.
cursor wasn't working. Yeah.
Okay. And yeah, of course, there's any questions as we go, because this I know is not normally been seen by most people. So I'm open to answering any questions about it.
So you mentioned earlier some things you're not patenting because they're trade secrets, which is a sound and often used method of, well, my bandwidth just got funny. But you do have patents on some things. So someone's asking about the patents on the things that you have patented.
Yeah, so the things that we have patented are the things that could be replicated and copied, right? So let's say, for instance, the blade design on, you can't really see, but when hopefully we go at the very end of this, I'll turn on the video, and then you'll see as this is spinning, the blade has a very specific design. It creates a Venturi event, something like a sailboat. So the blade design is patented. The array of the coils and the magnets, which with new types of nuclear resonant imaging, or nuclear, what is it, NMRI, nuclear magnetic resonant imaging, they could actually look into the composite and see the array of the coils and magnets, which didn't happen some years ago. So we actually had to patent that. But so it's a combination of some patents and some trade secrets. The things that couldn't be copied, that we keep as trade secrets, and the things that could be copied are patented.
Got it.
Okay. Let me come back here. Now, these are all artist renderings. This has not been built, but I think I shared a little bit earlier that the density of this is just radically different than anything that's been done before. In 2.2 acres, we could have 100 megawatts. And also interesting, since there's no metal, there's nothing to corrode, there's no moving parts, it's the perfect one for oceans. There's no back EMF, so it doesn't harm the whales. It could be put on barges, offshore. It really completely changes everything that we understand about the potentiality of wind as an energy source. So, yeah. And I'm going to go through this super quick on number 2. I'm not going to spend a lot of time on it. But importantly, the one thing I did want to show is that was a 82-foot That is an all composite commercial catamaran. We built that fully to basically show how the composite could work in the harshest environment in the world, which is an ocean. And you can kind of see how insanely light it is. In the bottom right-hand side, you've got one little crane holding up the entire vessel. We've also built a couple things that I can't share a whole lot about with a government agency with the composite and an ocean-going vessel. But we have a huge demand for it, but it just takes massive amounts of floor space. In regards to how fast we can do it, we're focusing on the other three first, but just to show that some things that we've already built out of the composite. And so this is the other thing that we're focusing on, which is the composite used for a shipping container. So we've built a 20-foot and 40-foot shipping container, and we've had it tested. And they do what's called a drop test from 4 feet, 6 feet, and 10 feet, and basically no damage. And we just met with a group put together by Maersk, M-A-E-R-S-K, in Spain recently. And they came up with the data that we could save about 6 million pounds of weight on one Panamax ship due to the weight savings, 6% the weight of steel of our container. And they first came back with an estimated 6% weight as a savings in fuel. They've upped that to about 20-something%. But importantly, which we did not know this, that after every 4th to 7th use of a metal shipping container, they have to take it off of the yard. They put it into like a field, and then they have to have somebody come in, a group, and x-ray it to look for micro fissures or micro fractures. And then they have to weld it or seal it up because water can get in the shipping container. They've calculated that they could probably go 1,000 uses as opposed to 4 to 7 with our container without ever having any maintenance. And the maintenance is the #1 cost of the containers, which we did not know about. And they can be watertight, they float, they don't rust. We actually have the DOD's interested in for projects that they're doing, in Canada and cold environments. So the shipping container is going to be a very significant market for us. We're just basically waiting. I don't know if you can see in the images, like maybe in the second one, you see a little shiny thing up in the top right-hand corner. Well, that's where the forklift goes, or the round lift. And those are certified and numbered, those little corner pieces. And so we're trying to get our composite certified so we don't have to buy those from a third party when we go to market. So that should probably be about another 6 months, and then we should have it certified. And then the entire thing could be composite. But it's really an extraordinary use of the technology. And the second and third one there, maybe we should have an image, but actually inside of there, where that door is, that's actually an inverter and a battery bank. And then the top of that actually comes up, and there's actually a wind turbine in there, and we call that power in a box. And it takes about 8 minutes to have it completely set up. Basically, the turbine just goes up like this. It's on a pivot, and then within 8 minutes, they have about a 400 to 600 kilowatt unit that's ready to produce power anywhere in the world. So there's going to be a lot of applications for this.
And the cost of one of these compared to a steel traditional container is significantly less or about the same?
Not significantly less, a little less.
Yeah.
A little less. Yeah. It's
Yeah.
now when we go to making our own corners, because those corner pieces are actually pretty expensive. I can't remember. I think for one container, there's something like $2,400 or $3,000 or something. But then for when we're making it for our own, it would go down to a few hundred. And then the cost would go down tremendously, which when the entire cost of the container is $12,000 or $14,000, you know, $2,400 is a big margin, is a big component.
I can't help, I've got to say it. They have a corner on the market.
Yeah, it's fascinating. There's only a couple people in the world that make those little things, and every one of them have a number stamped on it,
Yeah.
and it's registered, and you know it's insured by Lloyd's. So it's as you can imagine, it's a little bit going through that process. But
yeah, sure.
So that's the shipping container. And then the third is housing. So that's the house that we built in the bottom left-hand corner, and then in the middle of the right-hand corner. And you can see how light it is, that a little crane is lifting the whole house. I think it took us 4 hours to set the house up. So it got set on the piers, we bolted it in. And then I think one thing that's pretty cool to witness here is that on the second image, on the left-hand side, now all of the white things we bought from a vendor, but you know, the flooring, the walls, all of that is the composite material. So the composite can be made to look like anything, just depending on the texture of the form. It can look like wood, it can look like brick, it can be smooth, like if we want it for a ship or a shipping container. So we can have the material look like anything, and then we can include a color or a paint in the resin, and so basically it would never have to be painted for probably 40 or 50 years. So that bottom left-hand corner, it looks like wood, but it's our composite with a particular texture and a particular color. We're pretty sure it's the best material on planet Earth by a very, very large margin to build houses from. And one thing I probably should have mentioned, which I'm going to just maybe go back up real quick here on the transportation, which is one of the reasons that we're getting massive amounts of interest, is that we can also make the hull anti-fouling. And I did not know this until about a year ago, but you know, all the fouling material that builds up on hulls of very large ships is one of the biggest environmental challenges that there is, and also adds very significantly to fuel efficiency decreases. So that's the kind of things that we can do with the composite. So of course, the house is pretty much fireproof, and it can be just brought in one piece, put on either a flat platform or like that little hillside on piers, and it's put together in hours. And that's the house that we've built, and we have a very significant amount of interest for. And we've actually designed a little part that would go on the back of the house, where we could have the inverter and everything in a little module, so it could be completely self-contained also from a smaller turbine. You of course wouldn't need a megawatt for that. You know, you need maybe 10 kW. So that's the tiny home. And then the last application of this is actually in construction and building materials. So much of this is artist renderings, but the top images, so the one in the middle with like the little squares, the reason that's important is that's actually a truss for a bridge, for a 40-foot bridge span that we recently built. And if any engineers on the call, they would look at that and they go, oh, that's impossible that you would have something that thin that would be certified to build a bridge from. And then also on this, what I think, let me see, is it on here? Oh yeah, we do. Okay, didn't know that was here. Excellent. So probably most everybody's aware that a couple of years ago, Australia had millions of acres burned, from these fires that went everywhere. And so we joint ventured with a company out of Brisbane called King Composites. That's what we named it. And so we're now replacing millions of acres of fencing and gates and everything from the composite. And like, here's a good example. We're putting a yellow color in it so it can be seen. But it's non-conductive, so we can make it electric. It can't burn. There's a pretty cool video on King Composites, folks. But now this has brought us to the attention of many people in Australia, including the government, whereby they are just writing some rules about any new wind technology would have to be manufactured and deployed such as ours, with no transmissions, low maintenance, all of that. So Australia is going to become a very big market for us for many reasons. And now there's a pretty significant chain of hardware stores that want us to start making 2x4s, 4x4s, 1x4s, because it's better than wood, it's better than steel as construction material. So that's happening right now in Australia, and that's showing the material being implemented. So that's the super fast version of almost 2 decades of work into a pretty cool technology that has a lot of importance. I can, show all this stuff. Here's some of our patents. But I'll kind of come back.
We did have a question about sharing the patents and numbers and all that business. You can do that after. And as it relates to the tiny home, I think that this was a sample home that you built as opposed to taking orders for them now. Is that correct? Or are you taking orders?
No, that's correct. So basically, we have interest. We haven't taken orders because we don't really know for sure the exact final price. We know the one we built, what it cost us, but we know that everybody coming to us would like a house that's about 250 square feet larger than that. So once we build it, then we'll be able to tell people, okay, here's the price, and then we can begin taking orders. The containers, we know the price. The turbine, we know the price. But on the house, we don't know the finished price yet. We have somewhat of a rough idea, but we have to do a little bit.
Got it. There's a question about the fencing. Is the composite fencing plant in Australia or here?
It's not in either.
Yeah.
We've recently, I don't know if I have the little thing here. It's in Chinese, so I don't know if it matters anyways. But we recently received our certification, and I think you pronounce it Hainan, which is the trade-free port in China. But because of just a crazy relationship, we were able to get some manufacturing going in another country. But we're going to Australia on October 2nd and 3rd, and they have a location picked out and a building site. The initial building won't be big enough to fully go, but on the site we can expand. So we'll be moving the manufacturing to Australia in probably about 3.5 to 4 months.
Yeah, great.
Everybody really wants that as fast as possible.
It sounds like it. We get a couple questions here. The LOIs that you mentioned, or any of them related to the containers?
No, all the current LOIs are all for the wind turbine.
Got it.
Yep.
So there's a question about the tiny homes as it relates to insulation for winter and summer. How's that operate?
Yeah, so so let me make sure I got my numbers right. So at so 3/4 of an inch skin on the inside and outside, and then using our composite, which sort of looks like foam. It's not regular foam, but it's heavily aerated in the middle, gives us, depending if we go 2.5 or 3.5 inches, an R value between 28 and 34.
Yeah, I'm not in the construction business. I don't know how that compares to regular stuff, right?
Oh yeah, that meets or exceeds pretty much everything currently. Yeah.
Yeah, that's good.
And we could use a little bit more material, and but then overall we're going to a little greater thickness than 4 inches. But the more of the material we use in the middle, then the greater the R value.
That makes sense.
Yeah.
So I've heard recently, Mark, that there's a federally supported, I don't even know what to call it, program that has just been renewed for wind power. I'm imagining that just plays into the CapEx of what you're doing, right? Which just can do nothing but help.
Yeah, the amount of interest that's coming to us, it's it's pretty crazy. And we're just telling everybody, look, let us get our act together first, before we make any commitments or anything like that. Like, we just took these first LOIs just to let everybody know that's, potential capital partner, that, okay, the market really wants this. And it's kind of, you start to throw some numbers around, they start to sound goofy. Like you say, 1,000 gigawatt, which, 1 gigawatt is, $1.2 billion. And, right now we could probably, if we were fully supported, we could easily get 100 gigawatt of orders within 4 months.
Yeah.
So easily. Yeah.
So one last question. Does the material have any outgas? Oh,
No, zero.
yeah.
No VOCs.
Super interesting. Are you going to play this?
Yeah. So here's the turbine. So again, the handheld device is a wind speed meter, and I think you'll see it goes all the way down to about 2 point something miles per hour up to about 14. And you'll see I don't know if there's a lag time, hopefully not, but it's spinning at about 45, 50 miles per hour, which the physics and normal physics doesn't add up. But there you go. So you can see you've got a turbine with a top ring and a bottom ring that is magnetically levitated inside of those. So there's no bearings. There's nothing to ever maintain. There's nothing to ever break down. And the 1.1 megawatt unit would just be about 10 feet taller than that and about 4 feet bigger in diameter. But
I'm sorry, you've got pricing on this at some point, right?
Oh yeah.
Yeah. So let's talk about the ask and the use of funds.
Yeah. So what we know that we need to fully ramp up, two things. One is to finish our first facility, which allows all of the POCs to be done, all the proof of concepts. So in that, which we've designated a place in Ventura County, California, we have a building that we'd like to obtain as soon as possible. In that, we'll build the 20-foot, 40-foot shipping containers, the 1.1 megawatt unit with the pole for the 2.2, and then the 840 square foot home. And then we have 2 locations potential, one in Las Vegas and one in Reno, where we can scale manufacturing. So for all of that, which would include, the building purchase in Ventura, building leasing in the other 2 locations, and then equipment, inventory, and all of that, about anywhere between about 26 to 30 million. And so that's the ask, and that's what the use of proceeds are. Upon funding, we should be able to, it's going to take us about 90 days to outfit the facility, and then about 90 days to have everything ready to have all of the POCs, and then to begin converting all of the LOIs to purchase orders. So let's say about 6 months from funding.
Got it. And have you settled on whether that's straight equity, convertible note? It's open to discussion.
Yeah, it's open, definitely open to discussion. You know, we've got a group on one of our other projects that, you know, they just want to do debt financing, and then, you know, have it, you know, backed with an SBLC with, you know, a group that they work with, and outside of this project here. And so, yeah, it's really, I think it's going to depend on the individual, you know, what they're looking for. Definitely, it's not workable for, let's say, somebody that's looking, you know, to come in and then have an exit in 5 years. That's 100% not what we're wanting to do. I mean, I think if anybody had their dream scenario of what an exit would look like in 5 years, we'll probably be able to massively beat that in about the second year of income.
Yeah.
You know, and then you're, you know, have many years after that. But there's so many things that we can develop from the composite, you know, skyscrapers, rail, like so many things that we really want to be able to, you know, work with this over the next many years to develop the multiple opportunities for it.
Yeah, totally makes sense. So we have a bunch of folks that have mentioned on the chat that they want to speak. So we'll make sure everybody gets in contact.
Okay.
Is there anything else you want to add, Mark? You're in Northern California, and the manufacturing facilities will be as you've mentioned, because there was a question about where you are.
Yeah. So I'm in Marin County, just outside of San Francisco, and we did not have a summer.
Yeah, right.
The whole rest of the country did.
Yeah.
I just looked outside. It's getting blue sky. Okay. So yeah, so that's my corporate office, where my team is on the business side, and then our, you know, inventor, engineer, all that, they're down in SoCal. And then, you know, just because California is a very unique place to do business in today's world, we will do manufacturing and all of that outside of California. And there's a really unique opportunity with a building that should be done in about 90 days in North Las Vegas. And with one of our other projects, we are already in production up in Reno. So we have some relationships there. There's a couple places that could work, but North Las Vegas is looking very appealing right now. And then even some space that's just outside of Austin, Texas. So, you know, it's basically
a lot of interest in Texas these days. Yeah.
Yeah. But both, you know, have very good tax considerations, Nevada and Texas.
Yeah.
And very good business development climates and business support climates. So, yeah, so the manufacturing and the revenue will be either in one of those two places.
And is the funding for Centuri?
100%. Yeah.
Yeah. Okay. So I happen to know Mark has some other interesting companies, and so I just wanted to, you know, there's Centuri is what we're focused on here for this discussion.
Yeah. So yeah, the capital is one thing only, is to get up and going, get purchase orders, and get in revenue.
Yeah. Super.
Yeah.
Great. Well, thanks for doing this again, Mark.
Yeah.
Make sure everybody gets in touch with you. And Lauren, thanks for your help. And Adil, if you end up listening to this, big thank you to you as well. And super appreciate you doing this again. So thanks, Mark. And thanks everybody for being here and sharing with us. The only thing you can't make more of it, and that's your time. Till next time. Thank you, Mark.
Okay, my pleasure. Have a great day, everybody.
Bye-bye.